on the chapter Physics and Mathematics. According to A.C. Verma, written in his book Concept of Physics, that mathematics is the language of physics. So today we will learn something about the mathematical aspect of physics. Today we will learn vectors and scalars. Any physical quantity that we have learned earlier in our class 10 physical science book. So physical quantity can be classified as two things. One is scalar and another is vectors. So if we generalize this two thing, that is scalar and vector, we can learn in higher physics, higher school, higher class physics, that these vectors are nothing but the special cases of a tensor quantity. A tensor with rank 0 is called a scalar, and that tensor with rank 1 is called a vector. So scalar basically has one thing, that is the magnitude part. So it has only the magnitude. I want to buy 5 kg of rice. I want to buy 3 kg of sugars. I have traversed a distance 5 meter. I didn't mention the direction, whether it is along the north, whether it is along the south, nothing. It's only the 5 kilometer or 3 kilometer. It's just a value, just a magnitude. So it's a scalar. And when we talk about vectors, we just add a put term, we just mix a direction with the magnitude. We say 5 kilometer along north, we say 6 kilometer along south. Either it is north, either it is south, or it is west or east, whether it is northeast, whatever it is, we define a direction. So in that case, the vectors are of rank 1 tensor. So basically tensors are nothing but the higher rank vectors. We shall learn this in the upcoming lectures if we have some time. So basically we will define some sort of definitions of different type of vectors. So we will start with the equal vectors. Here these two vectors are parallel. That means they are directing in the same direction, if that is southeast. At the same time they have equal magnitudes. So in that sense they are equal vectors. If we talk about the opposite vectors, C is directing towards east and B is directing towards west. Okay, just take B vectors from here, you just put it here, it will be, the definition will be same. They are opposite vectors. So when you talk about the collinear vectors, these collinear vectors are given here. This vector A, vector B, vector C, vector D and vector E. These vectors either they are parallel or they are anti-parallel. So when we take all together, these vectors defines the collinear vectors. So one point should be noted, that the collinear vectors are either anti-parallel or parallel. They can have any type of magnitude. So don't worry. Taking from here to here, we have different types of vector directing to in a different directions, having different types of magnitudes, though these vectors lie on the same plane, and that's why all these vectors are called as coplanar vectors. And if we talk about the co-initial vector, let us come to this point. So they have started from a single point, is directing towards east, north, west and south. They are called the concurrent vectors or co-initial vectors, as they have originated from the same point. If any vector has a magnitude 1, if you are talking about in FPS system, that has a magnitude 1 fit. If we are talking about the MKS or SI system, it has a magnitude 1 meter. If you are talking about in CGS system, it has a magnitude of 1 centimeter. So the magnitude is unit or 1, and it has a direction is called a unit vector. We will learn more about unit vectors when we learn the 3-dimensional axis or 2-dimensional axis or 1-dimensional axis. We will learn in the upcoming lectures. So let us denote the zero vectors. The zero vectors are basically nothing but the the subtraction from a vector to another vector if the vectors have same magnitude. We can't put just 0. If we talk about the distance between one place to another, that will be a 0 because we haven't mentioned the direction there. But when we talk about the gravitational acceleration at the center of the earth, we talk about zero vector because when we are at the center of the earth, we can experience different type of force acting from a different direction. But at the center, if we put all the forces there, that becomes 0. As forces are the vectors quantity, so we can say that this 0 is nothing but a vector 0. This is not a scalar 0. So gravitational acceleration is 0 at the center of the earth, and this is a vector 0. So for today, this is okay. This is enough for today. We'll discuss further topics in the next upcoming lecture. We can discuss the position vector out there. So till then, bye.